Hello class, this is a video on single replacement reactions. The first one we're going to do is number 1 of the homework. This is silver plus potassium nitrate yields ? Now we want to start here with the free metal. We always start with the free ion, the free metal. Whichever one that one is, that's where we start. If we look at our activity series of metals, we know that potassium is much higher than silver. So silver would have to go upwards through the reactivity. This is the most reactive. Silver would have to go from bottom to top to replace it, and that doesn't happen. Therefore, silver will not overreact potassium. And because of that, it won't overreact. There is no reaction. It will stay in the reactant state, and we're done. So let's skip to number 3, aluminum plus sulfuric acid. And we're going to start here with the free metal aluminum. And if we look on our activity series, aluminum is much higher than hydrogen. And because aluminum is more reactive, meaning it's more unstable, this can replace. Make it a red mark. So aluminum will replace hydrogen. Aluminum will overreact hydrogen. So let's create a diagram. If we look at our sulfuric acid, we have a cation bonded to an anion, sulfate, SO4. Aluminum will then kick out hydrogen, and not just one of them, but both of them. So poor hydrogen gets left out here, while sulfate gets left as SO4 2-. So because aluminum is more reactive, it creates the bonds with the sulfates. And it creates those bonds, while hydrogen gas, H2, is left on its own. So it's kind of sad. Now if we look closely at AlSO4, because it's ionic bonds, the charges have to match. Therefore, this 3 is going to go down here to the subscript, and this 2 and go down here to this subscript. Therefore Al2SO4 is our final product, as well as H2 off here by itself. So if we look back at our original equation, our final product will be Al2SO4 plus H2. Now we have to balance the equation. The first thing I'm going to do is balance off the aluminum on the left-hand side of the yield sign. Next, I'm going to balance the sulfates on the left-hand side of the yield sign by adding a 3. And finally, because I have this 3 applies to this hydrogen, I'm going to add a 3 here to make that equal. Okay, and here is my final equation. 2 aluminum plus 3 moles of H2SO4 yields aluminum sulfate plus hydrogen gas. Now we're done. Check. Plus. So here are the steps of all of these problems. First, check the activity series. Make sure the reaction can occur. 2, replace the cations with the free cation. 3, exchange the ionic charges of the new compound. And 4, balance the molar coefficients of the chemical equation. Every problem, you have to do all of these 4 steps continuously. Okay, let's look at number 4, chlorine plus potassium iodide. Now, if we look at our periodic table, electronegativity increases as we go up a column. So iodide is less electronegative than fluorine. So similar to the activity series, this cannot happen. Iodide cannot replace fluorine. But fluorine can replace iodine because it's more electronegative and it's more reactive. So for metals, we use the activity series. For nonmetals or halogens, we use electronegativity. With that being said, this chlorine will kick out the iodine. And the poor iodide will be left out by itself. To put that in other words, chlorine will overreact iodine. So here's chlorine with its boot, and it kicks out the iodine, and then bonding to the potassium. And when we double check the ionic charges, potassium is +1, chlorine -1, therefore it's already a balanced molecule. But what about iodide? Well, if we think back to our first, and remember, iodide is part of F-high no Claybro. That means it's a diatomic molecule, and it comes in pairs. So therefore I2 will be one product, and then KCl will be another product. So we rewrite our entire equation, Cl2 plus Ki yields KCl plus I2, and now we have to just balance the final equation. The first thing I'm going to do is put a 2 here to balance off the two I's. But it also doubles the amount of potassium. And because I doubled the amount of potassium, I have to add a 2 here, which doubles that, and the chlorine, and then I check, I also have 2 chlorines over there, so now it's balanced. Here is our final equation. Chlorine, Cl2 plus 2 potassium iodide yields 2 potassium chloride plus iodine gas. And great job, check, plus. The only difference between nonmetals and the metal activity series is that for nonmetals we use electronegativity. So keep that in mind, otherwise the process is the same. Good luck, and let me know if you have any questions in class. Have a great night.